Okay, I apologize again. I have a new camera, so it's giving me a little bit of issue. A lot of technology going around that we have to learn for ourselves. There's nobody to help us, really no tech support. So we're on our own for the most part. So bear with me as we get through this rest of the semester. So I think we left off here, right? So we had that last couple of conditions that we need to check, right? We want to check the derivative of our functions at 1, right? So I'm going to use s of 1 prime at 1 equal to, we want to see if it equals to s of 2 prime at 1. Okay, is that the situation? So let's plug in. When we plug in 1 into s of 1 prime, we get 3 minus 2 equal to, plug 1 into s of 2 prime, we get 1. 1 is equal to 1. That is a true statement. That's good to go. So I guess the s double prime is probably the one that fails, right? So let's see if s double prime is an issue for us, right? Seems like all the other conditions were satisfied. Let's see if s double prime gives us issues. So let's do s double prime, s of 0 double prime at -1. Does that equal s of 0 double prime at s of 1 double prime at -1? Okay, all these guys. If I plug in -1 into s sub 0 double prime, I get 0. And if I plug in -1 into s of 1 double prime, I get -6. By the way, this is a false statement, folks. These guys are not equal. So this guy fails. Okay, get an X right there. But let's check the other one too, see if that one fails as well. Maybe that one's good. So does s of 1 double prime at 1, does that equal to s of 2 double prime at 1? Right? Now, let me just kind of say this before I do this one, right? If I find that one of these conditions fails, then this is not going to be a cubic spline. But I just want to see how many of these conditions actually fail, right? This is what I'm doing. So I want to just check it out to see how many of these conditions fail. So let's plug in 1 into s of 1 double prime. I get 6. And if I plug in 1 into s of 2 double prime, I get 0. This is also not equal. This is a false statement. So this one also fails. So I have 2 of these that fail. In my interior points, my interior knots of for my second derivative, these guys don't connect. So I can say here I can say that s prime of x is continuous. Okay. Because they're going to connect, my derivative is going to connect at the locations of -1 and 1. But here, s double prime of x is discontinuous. At x equals -1 and 1. Those two locations, right? Those two places where the function is discontinuous. And so I can say, without a shadow of a doubt, that s of x is not a cubic spline. Okay, so we are done with splines for the most part, right? We're going to be going to our next topic, which is going to be over derivatives, right? So look forward to that, and I'll see you guys next time. Bye. Oh, before I go, actually, I should introduce you to the teddy bears. This is Buford, right? This is Buford, and this is Genevieve, who I sometimes will call Guinevere, but it's supposed to be Genevieve. So I'll introduce you guys to the teddy bears that are taking your place until we meet again. Talk to you later. Bye.